Hey guys, what's up? Today we're looking at finding two unit vectors which are orthogonal to two given vectors, and we're going to use the dot product to do that. A lot of people would use the cross product to do this, which is okay, but we're going to use the dot product and what that means fundamentally to do this problem. So we've got two vectors here. A is I hat plus j hat, or I plus j, and B is the vector I plus k. So what we're going to do is we're going to find a unit vector that's orthogonal to both. So the vector we're going to find is the vector v, first of all, and then we'll make it a unit vector. So the vector v should dot with our vector a and give us 0. And also vector v dotted with vector b should give us 0, because we want this vector, this new vector v, to be orthogonal to both. So we'll let v have components v1, v2, v3. So v is equal to the vector v1, v2, v3. And notice that the vector a is equal to the vector 1, 1, 0, and vector b, we know, is equal to the vector 1, 0, 1. So now we take these dot products. So v dot a is equal to v1 plus v2. So v1 plus v2 equals 0. And the second dot product, v dot b, is v1 plus v3 equals 0. So v1 plus v3 equals 0. So this is going to tell us that v1 is equal to negative v2. Or we could say negative v1 is equal to v2. And same thing, we could say negative v1 is equal to v3. So our vector v should have the form v1, negative v1, negative v1. All right, so we'll let v1 be equal to 1, and then v would be equal to 1, negative 1, negative 1. But this is not a unit vector. So this is not a unit vector. To get it to be a unit vector, we just divide it by its magnitude. So we'll say u, unit vector number 1, is going to be v over its magnitude. And this one's not too hard to see that the magnitude of v here is square root of 3. So magnitude of v is square root of 1 plus 1 plus 1, which is square root of 3. So this unit vector number 1 is going to be 1 over root 3 I hat minus 1 over root 3 j hat minus 1 over root 3 k hat. The second unit vector, all we got to do is say u2 is going to equal the negative of u1, because multiplying by a negative sign just changes the direction, not the magnitude. So this the second unit vector is going to be negative 1 over root 3, 1 over root 3, and 1 over root 3. So I use some different notations here just to kind of familiarize you with all the notations we could come up with, but this is our second unit vector, and here's our first unit vector. And now these two are orthogonal to both of these vectors a and b.